Hi, my name is Travis Rector, and I'm a professor of physics and astronomy at the University of Alaska in Anchorage. I do research on a variety of topics. I do research on quasars. I also do research on how stars form. And I also do what's called science education research, which is studying how students learn. Well, my career in astrophotography started when I was a graduate student at the University of Colorado. There's an observatory at the University of Colorado, and we would have students do photography with the telescopes. And so that's how I first started doing it. And then I went to Kitt Peak National Observatory in Tucson around 1998. And at that time, they had just built a new wide field imaging camera called Mosaic, which is a 64 megapixel array. And so at that time, they asked me to try making some images with it to show what it could do. And the images came out well, and that's how I got started. Well, in astroimaging, we're no longer using film, of course. We're using digital cameras, but these are cameras that are quite a bit different than the camera you might have in your back pocket. These are cameras that can see kinds of light that your eyes can't see. We also have kinds of filters to see special colors of light that you can't differentiate. And also we put them on telescopes, which allow us to see things much fainter than what the human eye can see. So when we put these cameras on our telescopes, we're seeing things that are quite literally invisible. Your eyes can't see them at all. And so the challenge of what we do is to translate what the telescope and camera can see into something your eyes can see. And so that's where the astroimaging part comes into. And the challenge is making something that people can look at and understand. So people ask that all the time, is this what it really looks like? And to answer that question, I show them an image of a nebula, show what it really looks like, and it's just a screen of black. And that's because the nebula is too faint for us to see. So even the brightest nebula in places like the Orion Nebula and things like that are for the most part, too faint for our eyes to see. And so what we do is we take the data that the telescope can see and translate it into an image that, as closely as we can, might represent what your eyes could see if you had gigantic eyes that allowed you to see kinds of light that our eyes can't see now. So when people think of telescopes, they usually think of one thing that telescopes do, and they think of telescopes being like a giant pair of binoculars to magnify an image and make something that's far away look much closer, just like if you were at a basketball game and you're up in the cheap seats. But telescopes do other things as well. One of the things they do is they not only magnify an image, they also amplify an image. They make something that's very faint much brighter. And they do this in two ways. One is by having really big mirrors that can collect light so we can get a lot more light than our eyes can see, and also by taking longer exposures. And then finally, we have digital cameras that can see kinds of light that our eyes can't see. So things like ultraviolet and X-rays and infrared light. And so that's how a telescope gives us superhuman vision. And one way I like to think about it is what would be the point of spending millions of dollars to build these fantastic machines if they saw the exact same thing our eyes could see? Well, the different kinds of light tell us a lot about an object, and it really depends on what kind of object it is. So for example, if it's a quasar or a distant galaxy, by measuring the shift in light, we can tell how far away it is. We can also use light to do things like determine what kind of gases are in it or what temperature it is. And so there's actually a lot that we can learn. And so what's amazing is nearly everything we know in astronomy is from the light that comes from us, from the universe. Things that are, light years away or hundreds or thousands or billions of light years away. Things far, far too away for us to go and actually study. And so what's amazing is just from the light we get from these objects, we can learn so much about what they are. Well, I think what people find the most exciting is when they see something that's a combination of the familiar and the unfamiliar. When you're looking at objects in space, they may be of things that look totally different than anything you've ever seen on Earth, and maybe just too abstract or unusual for people to understand. Whereas a scientist who knows something about the object may know enough to be able to look at it and say, wow, this is something new and interesting. So the images we found that are most popular with the public are things that are exotic and familiar at the same time. It's as if your brain is looking at it and saying, wow, I've seen something like that, but never like this before. And so if you have those familiar cues, then it allows people to look at the image and be able to use the skills they have already to interpret it. We tend not to use the term false color anymore, and the reason why is that implies that what people are looking at is fake. that is just a creation with Photoshop or something like that. So one of the things I like to emphasize is in these astronomical images we make, all the things we're looking at are real objects in space. So we often use terms like natural color or representative color, things like that, when we're describing how the images are made. And so the difference between astronomical imaging and space art is where an artist is taking information about an astronomical object and then creating an image to help illustrate what that is. And so usually space art pictures are of things that are real, or at least imagined, and then using scientific information we might have about that object to help us to visualize what it is. But one thing that we try to do when we release these images to the public is make it very clear what it is they're seeing, whether it's an astronomical image made with telescope data or an artist's impression or conception based upon measurements we've done with telescopes. Well, I was saying that photography is like having children. Your photographs may be ugly, but you love them anyway because they're your own. The images I'm most proud of are the ones that are the hardest to make. The ones that we may have had like a really complicated data set, and it took a lot of time and effort, not only in the processing of the data, but also thinking about how we wanted to make the image so that it would not only look good, but also tell an interesting story. Because what we want to do with our images is make an image that people say, wow, what is that? I want to know more about it. And so they look at the image and then they read more about it. So those are the images I'm most proud of. Those aren't necessarily images of mine that have become the most popular. As far as science images go, there's images like the Hubble Deep Field, the cosmic microwave background that just have an insane amount of science in them. And scientists, even today are still pouring through those images to learn more about what's in there. So those are the images, those examples of images I think are really amazing.